Depending on your airline, some aircrafts are equipped with BACF or Braking Action Computation function, and this makes it easier for pilots to report the braking action. Dear guests, welcome back to the channel. Today, let us discuss what is GRF, also known as Global Reporting Format. So first, let us talk about landing performances and contaminated runways. The pilots are now responsible to assess the runway condition. Talpa ARC model was introduced in 2009, and with this, Airbus inserted this table here, which is the RCAM or Runway Condition Assessment Matrix in the QRH. However, right now, the condition codes are now included in the SNOTAM and ATIS. So these codes, for example, code 5 is directly inserted into the Airbus FlySmart software, so the RCAM tables are no longer required. So to be able to notice the differences, let us look at how we used to calculate the landing distance before GRF was introduced. So back in those days, the SNOTAM will provide the code and also the thickness of the snow. So example, code 4 is dry snow and 10 is 10 millimeters of thickness. So in this case, we use the RCAM tables to determine the braking action. The code we obtain will then be inserted into the FlySmart software. So after the implementation of the GRF, the runway condition code is now available in the SNOTAM and ATIS. This makes it easier for pilots, as all they need to do now is to insert the code into the FlySmart software. Question: how is the runway condition code measured by the airport authorities? It is based on mainly observation and also measurement of the coefficient of friction. When the airport authorities observe a change in runway conditions, they will either upgrade or downgrade the code. Let's take an example. We all learn from examples. This is the weather information from ATIS. So the contaminant is ice and it is a code 1 on the RCAM. But based on the observation, airport authorities decided to upgrade the code to code 3, corresponding to medium braking performance. The airport guys probably have performed some procedure to make the runway condition better. So take the code 3 and plug that number into your computation. Bear in mind, if situation changes, we, the pilots, can downgrade that number based on our observation. Remember that pilots can only downgrade the runway condition code and not upgrade it. When the condition of the runway is reported, it is always based on each portion of the runway. For example, 5, 4, 3. The runway condition code 5 is for the first runway third, 4 is for the second runway third, and 3 is for the last segment. To be conservative, always take the lowest number for your computation. However, please use your own judgment. If you take the second lowest runway condition code, calculate it, and you can land and stop before the last portion of the runway, then you can disregard the last portion. So in this example, take the number 4 and compute the landing distance. But this will only be useful if you find that the last portion of the runway is very much degraded. For Crosswind Limitations, do refer to the RCAM under the AFCON subsection Performance EFB page. It is the pilot's responsibility to report on the braking action and compare it with the ATIS. Depending on your airline, some aircrafts are equipped with BACF or Braking Action Computation function, and this makes it easier for pilots to report the braking action.